Okay, so here I am in Onenote. Like I said, you can use Microsoft Word to type out what your robot's going to have. You can use actual paper to draw out or even type out or write out what your robot's going to have. I'm just going to use Onenote to draw out what my example robot's going to have on it, the type of hardware it's going to have. So I'm going to start off with my poorly drawn chassis. It wasn't too bad. And then I'm going to start off with my robot's going to have 2 drive motors. So my 2 drive motors, this will be, here we go, drive motors. This one's obviously going to be my left, and this one will be my right. I also want something else in my robot. Let's say a claw, a 2 servo claw. So I'll have 1 servo, 2 servo, me opening and closing up like that. Just say like that for an example. And then let's see, something else to my robot. I can have a flywheel for some reason. You want to do like a flywheel design. If you know what that is, it's when you have 2 wheels connected to a motor which are moving in the opposite direction, which cause an object to fly out here. We can do something like that. So that means that this will be my left flywheel, this will be my right flywheel, and these have to be spinning in opposite directions. So this will be spinning in a counterclockwise motion. This is clockwise. Okay, so now we drawn out what our robot's going to have on it, or drawn out some mechanisms. Let's just go ahead and make a list. Let's see, 4 motors, and it really doesn't matter what kind of motor is using. You can use Tetrix, AnyMark. In the programming, it's not going to matter. It's all going to be used the same. You'll see in a little bit. And we're going to have 2 servos. And same for servos. It doesn't matter if you're using continuous rotation or if you're using a 180 servo. If we program it correctly, it's going to be working correctly. And trust me, you'll be programming correctly.